Hello guys, welcome to our YouTube channel, Maths. Today we're going to discuss a very interesting problem on finding the limit of an integral. So the problem goes something like this. Limit p times to infinity integration from 0 to 1 x to the power p to the power x dx. So to solve this, we can proceed something like this. First of all, we can rewrite this integral as follows. X to the power p to the power x is equal to x to the power p to the power x minus p plus p times h to the power. Let's call this equation. Now, look at this value. We touched it from 0 to 1 and this term. We get limit we comes to infinity and this integral is nothing but p upon this one. And this limit is nothing but 1. Let's call this number 2. Now, let's look at this term. We're going to use Lagrange's mean value theorem to simplify this term. Let's see how. So, Lagrange's mean value theorem says that if f is a real valued function defined on closed interval b and it is continuous and differentiable on open interval. So, continuous on closed interval and differentiable on open interval, then there exists C in the open interval A to B such that f of b minus f of a upon b minus a is equal to f prime c. By f prime c, I mean to say the derivative of m at x equal to c. I'm going to use this result for this term. Let's see how. So let's take fx is equal to b to the power x minus b and look at the interval x. Now let's apply this Lagrange's mean value theorem. So it says that there exists a c. Let's write this c as c subscript x because this c is depending upon this. So I want to show this dependence by this subscript x. There exists a subscript x in the open interval x comma 1 such that f1 minus fx dot 1 minus x is equal to f prime c x. And what is f prime? What is the derivative of f? Well, this is equal to 3 to the power cx everything. So, what is f of 1? F of 1 is b minus b. What is it? So, we have f of x plus 1 minus x into the power c sub x ln b. And fx is e to the power x minus. And therefore, we have x to the power times e to the power x minus b equal to minus e to the power cx x to the power b 1 minus x. Now, note that this is a positive quantity because x is in closed interval 0 to 1. So this can't be negative. So 1 minus x is positive, x to the power p is positive, and log of p is also positive because p is tending to infinity. So we can take p to be very large, and therefore log of that is going to be positive. And similarly, e to the power cx is also going to be positive. Now, c to the power x is in the open interval x to 1. And therefore, b to the power cx is less or equal to e. But since we have minus sign, so this inequality is going to flip. So we can say that this whole one is greater or equal to minus b times x to the power b times 1 minus x ln. Now, integrating both sides, I will get 0 to 1 x to the power b e to the power x minus b greater or equal to ln b b integration x to the power b 1 minus x. And this comes out to b times ln b upon b plus 1 b plus 2. And let's not forget the minus. And sign is also there. Now, note that this is a negative point because x is less or equal to 1, and therefore 2 to the power x is less or equal to 2, and therefore 2 to the power x minus 2 is less or equal to 7. So this is a negative. So we can say that it's less or equal to 0, 0 point x to the power b, 2 to the power x minus 2 to the power 2 minus b, and then b. Just erase this. B plus 1, B plus. Now, what is the limit of this quantity? B, we can take B common. So we get B square 1 plus 1 upon B and 1 plus 2 upon B. So B cancels from only one B is left. And here we have ln B over B. And these are finite terms. And what is ln B over B? As B tends to infinity, this is 0, right? So this is 0. So limit of this quantity is 0 and limit of this quantity is 0. Therefore, by sandwich theorem, or by the squeeze theorem, whatever we call these theorems, we have limit b tends to infinity x to the power b to the power minus x minus 2 equal to 0. Let's call this theorem. So if we integrate both sides, so if we integrate both sides here, what do we get? And if we take limits, so we get limit b tends to infinity x equal to 0 to the power 0 to 1, limit it to infinity, x to the power e to the power x minus plus 0 to 1, e to the power b, limit it to infinity. Now, we know this by number 2 that this is equal to 1. And we know by number 3 that, so this is equal to 1. And by number 3, we know that this quantity is equal to c. So, overall the limit is 0 plus 1 equal to 1. And therefore, the limit that we desire comes out to be 1. This completes the solution to this problem. Thank you for watching this video. I'll see you in the next video. Bye bye. Take care.